Every year, between 80 billion and 150 billion units of Adidas clothing are produced worldwide. But what about footwear, which holds the second largest production volume in the world? Recently, Adidas has seen a significant surge in popularity for its retro models, such as Samba, Campus, and Handball Spezial. According to the online platform StockX, Adidas sales increased by 51% compared to the previous year. Let us dive into the production of these legendary sneakers and see how new footwear is brought to life. The process of creating a new Adidas shoe model begins long before the first physical samples reach the production line. Dozens of specialists from different fields take part in this process: designers, marketers, engineers, technologists, and even sports consultants. Adidas designers constantly analyze market trends, researching which models are currently in demand, which technologies are evolving, and what consumers prefer. This includes analyzing past sales data, studying fashion trends in streetwear and sportswear, monitoring competitors such as Nike, Puma, and New Balance, tracking new materials and innovations in manufacturing, and conducting surveys with professional athletes and regular users. This process can take anywhere from several weeks to several months, depending on whether it involves updating an existing line or creating an entirely new concept. Once the team gathers enough information, the concept development phase begins. Designers create the first sketches, plan the shape, position logos, and select material and color combinations. At this stage, it is crucial to find the perfect balance between style, functionality, and comfort. Interestingly, Adidas frequently uses specialized three-dimensional modeling software that allows designers to create realistic digital images of future shoes. This helps save time and provides a more accurate visualization of how the model will look in reality. This exciting process can involve anywhere from 10 to 50 people, depending on the complexity of the project. This includes not only designers, but also biomechanics specialists who assess comfort and foot impact, technologists responsible for materials, and even marketers who propose changes to meet consumer expectations. Designers may suggest a stylish solution, but if it is uncomfortable or does not meet technical requirements, such as weight, material durability, or breathability, it must be revised. Some ideas are impossible to implement due to technological constraints or excessively high production costs. Adidas is actively working to reduce environmental impact using recycled materials and eco-friendly technologies, which also influence design decisions. After the first physical prototypes are created, Adidas puts them through rigorous testing to evaluate comfort, durability, and compliance with stated characteristics. This stage assesses material quality, seam strength, and overall resilience before launching the model into mass production. Shoes are placed in specialized machines that simulate walking or running through thousands of cycles to test the wear resistance of the sole and upper materials. The sole bends thousands of times to check for cracks or deformations. The shoes are submerged in water or exposed to moisture to test their resistance to soaking. The force required to tear fabric, seams, or glued elements is measured. Adidas employs robotic systems that replicate real-life usage conditions. Special robots simulate foot movements during running, jumping, and sharp turns. Shoes are subjected to extreme temperatures to assess material behavior. Shock absorption and impact resistance are analyzed using sensor platforms. No footwear enters mass production without undergoing real-world testing. Adidas collaborates with professional athletes who wear new models during training and provide feedback. Key testing aspects include comfort during running, jumping, and prolonged wear, foot and ankle support, breathability, and adaptation to different surfaces such as asphalt, grass, and hardwood floors. All these stages can take anywhere from several months to a year, depending on the model's complexity and the number of necessary adjustments. If a prototype fails testing, it returns for further refinement. Adidas works with suppliers worldwide. For example, the Boost sole was developed in collaboration with the German chemical company BASF. This revolutionary sole consists of thousands of expanded thermoplastic polyurethane pellets that provide high energy return. Once all necessary materials arrive at the manufacturing facility, one of the most crucial stages begins: cutting and preparing shoe components. From large fabric or leather rolls to sheets of synthetic materials, all components are placed in designated cutting zones. Workers or automated systems load materials into cutting machines according to the production plan. Modern Adidas factories use automated feeders that evenly unroll fabric or rubber for precise cutting. Laser cutting is used for thin synthetic materials and mesh fabrics like prime knit, as well as for intricate designs requiring high precision. Mechanical cutting is performed using press cutters or automatic knives following program templates. This method is ideal for leather components and thick fabrics. High-precision computer numerical control cutting machines can simultaneously cut hundreds of pieces from different materials, significantly accelerating the process. To minimize waste, software analyzes the most efficient way to position shapes on the material. Leftover scraps from cutting may be used for smaller components or other shoe models. Some recycled materials, such as Parley Ocean plastic, undergo secondary processing for reuse in future products. After cutting, components undergo additional technological treatments to achieve the required properties. Lamination is used to reinforce fabric and improve its performance characteristics. For example, running shoes may feature multi-layer lamination to enhance waterproofing and durability. This process includes applying special polymer coatings or thermal adhesives to increase material strength. Some shoe elements, especially those containing thermoplastic components, go through a heat molding process. When heated to a specific temperature, the material becomes pliable and takes the desired shape. Once cooled, it retains its structure. This method is used to create rigid heel cups or supportive inserts in the sole. Adidas employs several branding techniques for footwear. Thermal printing embeds logos and textured patterns into fabric or leather under high temperatures. Embossing creates raised logos on leather and synthetic components. Embroidery is used on textile models, such as the Stan Smith series. Reflective coatings enhance visibility in low-light conditions. Right now, take a closer look at your sneakers and comment on which branding method was used on them. Cutting takes anywhere from several minutes to an hour, depending on model complexity and materials used. Component preparation, including lamination, heat treatment, and logo application, can take several hours to a full day, as some steps require drying or curing time. Can you believe how much time goes into something that seems so simple? Incredible. The entire process is automated, but key stages involve operators who monitor quality and make adjustments. Adidas is currently experimenting with three-dimensional printing of shoe components, which could revolutionize cutting processes. Laser cutting also enables the creation of complex ventilation holes in shoes without additional stitching. Using laminated materials improves waterproofing without increasing shoe weight. After completing all preparatory stages, the finished components move to the next critical phase, sewing and shoe assembly, where they begin to take their final shape. Sewing machines join individual shoe upper parts, ensuring durability and a polished aesthetic. Adidas production lines use specialized automated sewing machines that operate at high speed and run continuously for extended periods. These machines execute various stitch patterns with precision, ensuring both strength and clean seams. As materials pass through multi-step mechanisms, needles create perfectly aligned stitches that form even and neat seams, enhancing shoe durability and longevity. Once all upper shoe parts are combined into a unified structure, the machine completes the final touches, reinforcing stitches, securing details, and performing quality control. Every component is perfectly aligned and interconnected. As a result, nearly finished footwear emerges, transformed into a functional and stylish product through a blend of mechanical precision and human craftsmanship. Some models feature seamless technology to enhance comfort and reduce weight. Soles are formed by molding material under high pressure to achieve the required shape and properties. Once the upper shoe parts are stitched together, the next step is attaching them to the sole. High-quality adhesives are applied to specially prepared surfaces. These adhesives create a secure bond between components, preventing detachment during wear. Next, shoes pass through a conveyor system, where each pair enters specialized pressing machines. These machines use high pressure and temperature to tightly fuse the sole and upper, ensuring a strong bond. The conveyor smoothly moves each pair through multiple stages, from adhesive application to pressing, undergoing a series of heating and cooling cycles to finalize the adhesion process, making the shoes durable and ready for further stages. Sell 100 million pairs of shoes in a year? What kind of production can pull that off? You won't believe it, but Crocs did just that. Today, we're gonna walk the path of the world's lightest footwear, from a polymer bead to a cult favorite. And from that cult, we'll move on to recycling these shoes. Crocs was founded in 2002, and their products instantly took over the world. The manufacturing process of Crocs is pretty complex. It all starts with the raw materials. They're the key to Crocs' success. The material they're made of is called Croslite, a patented foam resin that provides lightness, comfort, and durability. It's not just rubber shoes like many people think, but a special closed-cell foam material. Croslite is a type of ethylene vinyl acetate, a polymer material that boasts water resistance, cushioning properties, and high wear resistance. Polymers for Croslite are produced from oil or natural gas, which are processed into polyethylene. Large chemical enterprises located in Asia, Europe, and the USA supply this raw material to Crocs factories. The raw material is transported in the form of pellets. They're easily shipped in large containers and stored in dry conditions until production begins. The main Crocs manufacturing factories are located in Asia, Vietnam, China, and Indonesia. These countries have access to affordable labor, large volumes of raw materials, and robust logistics. The name Crocs comes from the word crocodile, because these animals can live both in water and on land, just like these shoes. Now, let's head over to the production line, bro. Check out how these guys load the pellets into a special machine where they're heated to high temperatures. It's seriously hot. The melting temperature of the material reaches 400 degrees Fahrenheit. The material melts and becomes liquid, resembling thick cream. The liquid polymer is poured into special molds that shape the shoes. The molds are subjected to high pressure, ensuring all the details are filled tightly. Excess polymer oozes out under pressure from the mold, kinda like creme brulee. If it weren't for the smell in the factory, you'd be tempted to take a bite, right? But it's definitely not something edible. As it cools down, the material expands, creating Croslite's unique closed-cell foam structure. This provides lightness, elasticity and softness, water resistance, and antibacterial properties. The shoes weigh on average only about 5 to 7 ounces. Confess it, who's gonna run off to weigh their Crocs after watching this video? But let's keep going, bro. Shoes made from these amazing pellets don't absorb odors and are easy to clean. But all this happens after they're taken out of the mold. That's when the excess material is trimmed off and the edges are smoothed. Look how quickly and precisely these guys work. The surface is polished to avoid burrs or roughness. It takes less than 5 minutes to produce one pair of Crocs. After trimming the excess material from the mold, the cut edges are treated with grinding machines. This is done to remove sharp edges, burrs, or irregularities left after trimming. First, they use abrasive belts or discs with medium grit, which quickly remove large irregularities. Rotating grinding tools allow the edges to be processed evenly and replicate the shape of the sole and the upper part of the Croc. Then, the workers move on to fine polishing. To ensure the surface is soft and smooth, they use fine grit abrasives like sanding sponges. This stage removes microscopic roughness that could cause discomfort when wearing. For particularly sensitive areas, like the edges of the ventilation holes, they use hand tools, like sanding sponges or polishing pads. Hand polishing guarantees the absence of even the smallest burrs. In the US, the military uses them as shower shoes because they're water-resistant and dry quickly. Other elements are added to the finished shoes, namely straps and gibbets. The straps for securing are attached separately. They're made from the same material or from more rigid polymers. Rivets are installed on the straps, allowing them to move. What kind of gibbets do you have, bro? Gibbets are decorative accessories that attach to the ventilation holes of Crocs. They allow you to personalize your shoes by adding elements that reflect your individuality, hobbies, or even mood. The idea for decorating Crocs came about in 2005. It was invented by Sherry Shubitsky, a mom who, together with her kids, came up with a way to adorn Crocs with tiny plastic charms. Let's all write in the comments, "Thank you, Sherry." Sherry used regular decorative buttons that her kids attached to the ventilation holes on their Crocs. The idea was so popular among friends and acquaintances that it eventually turned into a full-fledged business. In 2006, the Crocs brand bought the idea for $10 million, adding gibbets to their official product lineup. Gibbets are small decorative elements made from soft plastic or silicone. They have unique shapes and a special fastening mechanism. Gibbets can be in the form of symbols, emojis, logos, favorite movie characters, animals, plants, inscriptions, and so on. The back of the gibbets has a small stem or pin that fits into the ventilation hole of the Crocs. Thanks to the material's elasticity, the gibbets easily inserts and holds very securely. First, designers create sketches of future charms. These can be popular symbols, current memes, or seasonal themes. For example, snowmen in winter or sunflowers in summer. After the design is approved, three-dimensional models are created, which are used to form production molds. Liquid plastic or silicone is poured into molds with detailed designs. After cooling, the material solidifies, retaining the shape of the charm. Simultaneously, the back fastening part is formed, ensuring a secure connection with the Crocs. In 2021, a unique gibbets was sold at auction for $10,000. It was made of gold and adorned with diamonds. As for coloring and applying patterns, various techniques are used here, as you can see. Color is added at the stage of melting the pellets so that the color is evenly distributed throughout the structure. And to create print, they use laser engraving or printing techniques. Each pair undergoes quality checks for compliance with shape, color, and absence of defects. If defects are found, such pairs are discarded or sent for recycling. And that's the end of the production cycle. The finished Crocs are packed into boxes and transported by sea containers or by air to warehouses around the world. Crocs are comfortable shoes, but they present an environmental challenge. The Croslite material isn't a traditional plastic. At the same time, the Crocs brand is making efforts to make its products more eco-friendly and to find effective ways to reuse old shoes. The patented foam material doesn't decompose naturally, so if you throw out old Crocs, they can remain in landfills for decades. Croslite doesn't lend itself to standard plastic recycling methods due to its unique chemical structure. Recycling requires special technologies that most waste processing facilities don't have. You get it, bro. They invented a unique, durable material. But now, the problem is what to do with it afterward. In the past, Crocs implemented a program to collect old Crocs. They disinfected, refurbished, and passed them on to people in developing countries. So, we're cluttering up not our own country, but those who don't have a choice. Controversial idea, huh? That's why the program was discontinued, but it inspired the creation of new eco-initiatives. In some Crocs stores, you can leave your old shoes, which are sent for research into reuse or for conversion into energy resources. Today, old Crocs are sometimes used to obtain energy through the process of pyrolysis. Croslite is burned in special furnaces, and the energy obtained is used for heat or electricity production. Admit it, that's a pretty good look. Also, after shredding, old Crocs can serve as the basis for new materials, such as rubber coatings for playgrounds, insulation material, or as construction or decorative elements. Every year, we produce approximately 101 million short tons of textile waste, and more than half of that trash simply rots in landfills. But what if we could turn it into something useful? Imagine this: your favorite t-shirt, a stylish blazer, or even designer sneakers, all made from plastic bottles. Yes, fashion is already changing, and brands are turning waste into trendy clothing. How exactly does plastic become fabric? Why are large companies already earning millions from this? And does such clothing truly save the environment? Let us figure it out. Every year around the world, Approximately 101 million short tons of textile waste are produced, of which only 15% is recycled, while 57% ends up in landfills. We need to do something about that, right? It might sound like science fiction, but in fact, plastic can be easily recycled into fabric. Let us start with the fact that most of the textiles we wear every day consist of synthetic fibers, such as polyester. Here is something interesting. Polyester is nothing more than plastic. Yes, you understood that correctly. Plastic bottles or other plastic waste can be turned into fibers that are then used to make fabrics. The process looks like this. Old plastic bottles, plastic containers, or even damaged plastic items are collected, washed, cut into small pieces, and then these pieces are melted down into new plastic fibers. These fibers are then woven into fabric that, in terms of its characteristics, is almost no different from traditional materials like cotton or wool. Now imagine this. It is not just a technological marvel, but also a chance to reduce the amount of plastic that ends up in nature. This usually happens in the following way. Plastic is sorted by type of plastic, most frequently polyethylene terephthalate, and by color. Clean and transparent plastic is more valuable because it is easier to obtain high-quality raw material from it. After that, the waste is washed in special baths to remove any remaining beverages, glue, and labels. Then, special industrial shredders equipped with sharp blades cut the plastic into uniform fragments. Sometimes water cooling is used for this purpose. In order to avoid overheating the material, the smaller the plastic is shredded, the easier it is to melt and clean it from impurities. Next, the shredded plastic is heated to about 932 degrees Fahrenheit until it becomes a viscous liquid mass. Then, this melted mass goes through special filters to remove any remaining contaminants. After that, it is extruded through fine nozzles, creating thread-like fibers. These fibers are cooled by a stream of air or water, after which they are twisted into yarn that becomes the basis for textile materials. It is impossible not to notice that fashion is now moving towards sustainability. All those popular brands we know and love, such as Adidas, Patagonia, and Stella McCartney, are increasingly using recycled plastic in their collections. However, let us pause here. What makes this plastic so popular? Environmental friendliness. As we know, plastic is one of the biggest enemies of the environment. Every year, millions of short tons of plastic end up in landfills or in oceans. But through recycling, we can reduce that impact by turning plastic waste into useful materials. And this is not just one of the eco-initiatives of brands, it is a real shift in the industry. Interestingly, some designers and brands already use textiles made from recycled plastic, not only for environmental benefits, but also for the unique look. In particular, materials made of plastic fibers can have very intriguing texture and sheen, which gives clothing a bit of an innovative and futuristic appearance. Imagine a t-shirt that is not only made from plastic, but also has a striking texture that reminds us of the future. Research shows that reusing textiles can save up to 8 short tons of carbon dioxide and approximately 164 gigajoules of energy for every short ton of textile waste. Converting that to American measures, 164 gigajoules is about 155 million British thermal units. Recycling textiles saves 5 6/10 short tons of carbon and about 116 gigajoules of energy per short ton, which is around 110 million British thermal units. That is a considerable difference on a global scale. Technology. Fabrics made from recycled plastic can be just as comfortable and stylish as regular fabrics. They even have certain advantages. They are water repellent, resistant to fading, and they hold up well to wear and tear. Moreover, if these fabrics are processed correctly, they can be made soft and pleasant to the touch. And here, we should remember another point. Microplastic that can enter water through recycled fabrics. When we wash clothes, especially items made from synthetic materials, microscopic plastic particles can get into the water. However, some brands are already working on solutions to minimize this impact. For example, they use special technologies to reduce the release of microplastic during washing, or they create materials that are less prone to this. Innovation. However, It is worth noting that this is not just a trend. It is an innovation. Instead of continuing to produce more plastic, brands are finding ways to use what already exists. This opens up new possibilities for the fashion industry. For instance, one of the most fascinating technologies is recycling ocean plastic. The same plastic that is flooding our oceans can also be turned into clothing. For example, the company Parley for the Oceans creates materials from plastic collected from the oceans. This not only helps decrease the amount of plastic in the water, but also becomes the foundation for eco-friendly collections by brands such as Adidas. That is a whole different story, right? If you think that recycled plastic is something only for sportswear or accessories, you are mistaken. Imagine a stylish coat or an elegant dress made from material that was once a plastic bottle. These recycled plastic fabrics make their way onto the runways of major fashion shows and become part of refined collections. One of the most interesting examples is the Stella McCartney collection, which recently introduced a clothing line made from fabrics produced from recycled plastic bottles. And of course, you will not find any trace that these fabrics were ever anything else. They look and feel completely sophisticated. This is not merely about disposal. It is about creating genuine art out of what we used to throw away. Speaking of scale, some countries, such as the Netherlands or Sweden, have become true leaders in plastic recycling. There are even specialized factories there that transform plastic waste into textile, which then becomes part of both sports and everyday clothing. It is an entirely new approach to waste processing that not only helps preserve resources, but also creates new jobs. It turns out that the process of recycling plastic into textile not only saves the planet, but also has significant economic potential. Many small startups around the world have begun to build business models based on the collection, recycling, and resale of plastic waste in the form of clothing. Such businesses often collaborate with local communities, involving them in collecting and recycling waste, which creates new jobs and stimulates the economy at a local level. Technologies of three-dimensional printing also use recycled plastic to create fabrics. Some companies have already started making textile materials by utilizing plastic waste through three-dimensional printing. This allows the creation of entirely new textures and shapes, as well as optimizing the clothing manufacturing process. Imagine clothing that is literally printed using plastic. In recent years, the so-called smart fabrics have also been gaining popularity in the textile industry. Materials that can change their properties depending on the surrounding conditions. Recycled plastic has a role here as well. Some brands are experimenting with integrating nanotechnologies into fabrics made from recycled plastic, enabling the creation of textiles that respond to temperature or moisture, making clothing more functional and comfortable. It sounds like something from a fantasy, but there are already materials made from recycled plastic that can self-clean. They have special coatings that allow the fabric to repel dirt and water. This technology can change the rules of the game in terms of durability and convenience, because clothing made of such fabrics would require much less washing. Another exciting direction involves fabrics that alter their appearance depending on how a person interacts with them. For example, fabrics that respond to body heat or change color during movement. All of these innovations can be created using recycled plastic, opening up new opportunities in fashion. One more interesting aspect is the recycling of plastic into artificial leather. Some innovative brands have already started making eco-friendly artificial leather out of recycled plastic waste. Such leather can be used to manufacture bags, footwear, and even outerwear. This offers a material that resembles genuine leather, but without the use of animal products and with a smaller environmental impact. Here is the thing. Today's youth is a generation that is becoming increasingly aware of environmental issues. You are no longer just buying clothing. You are buying clothing that tells a story. You are buying not just fabric, but a certain idea. A future that can be more sustainable and clean. And when you wear clothing made from recycled plastic, you are not merely shopping. You are joining the change. You are becoming a part of this large movement. Of course, there are questions about the cost, quality, and availability of such materials. But do you know what? It is only a matter of time. With the advancement of technology and the growth in demand for eco-friendly products, these fabrics will become even more affordable. And that is great, because each of us can contribute to improving the situation. Perhaps in a few years, we will only wear clothing made from recycled material. And, to be honest, that does not seem so fantastic. It might become the norm, rather than the exception. And who knows, maybe in the future, even your favorite brand will use plastic waste to create new trendy items. Yes, it sounds like science, but science and fashion can accomplish many wonders together. So the next time you are choosing what to wear, think about this. Maybe it is another step toward a better world. And if plastic waste can become part of your style, then why not?
Ready to explode with curiosity? In this video, we're about to open some top-secret doors to the world of fireworks and firecrackers, things you never even knew existed. Stick around, and you'll see how a simple blend of gunpowder turns into the magic behind the brightest blasts. You'll get the lowdown on the wild history behind their creation and the unusual secrets of master pyrotechnicians. This segment will get your heart pounding faster, trust me. Watch till the end, because the best part is still ahead. Stay with us all the way through, and you'll find out something that'll totally flip your perspective. Don't miss out. Firecrackers, they're the more hot-headed guys in this family. Their main trick? It's all about the sound, not the show. Sure, they're simpler in design, but they deliver the same kind of magic. Noise and pure adrenaline. Like fireworks, firecrackers use black powder as their base, but the approach here is a bit more straightforward. The key is nailing the right balance to get a powerful boom without any extra fancy effects. Typically, a firecracker contains a black powder mixture, a casing, and a fuse. We'll get into what's inside later, but for now, let's talk about the casing. It's usually a paper or cardboard cylinder that holds everything together. The material's gotta be strong enough to hold off the blast till the big moment, but not so tough that it creates dangerous shrapnel. The fuse is the most critical part. It sets off the entire explosive process. It could be a thin cotton wick soaked in chemicals or more modern ignition systems. How are firecrackers made? All the ingredients for the black powder mix are measured out with serious precision, then blended to get the perfect consistency. Accuracy is huge here. Just a little extra saltpeter can make the explosion go wild. Too little, and the firecracker won't ignite at all. Paper or cardboard tubes are cut to the needed length, then carefully loaded with the black powder mixture. These casings typically have sealed ends to build up just the right pressure for the explosion. At the top of the firecracker, a small hole is made for the fuse. The fuse is inserted and held in place with glue or a special sealant.
The bottom and top edges of the firecracker are sealed tightly, often using glue or heat bonding. This ensures safe storage and transportation. Next, the firecrackers undergo careful testing. Manufacturers check the sound level, ignition speed, and quality of the explosion. Not all firecrackers are created equal. Cheap ones often have uneven filling, weaker sound, and a bigger risk of misfiring. They use lower quality materials, like plain paper instead of sturdier cardboard. High-quality firecracker casings are made from sturdy yet lightweight material. The black powder mixture inside is evenly distributed for a consistent effect. The fuses have a precise burn time to give you enough seconds to back off to a safe distance. Making firecrackers is no joke. Pyrotechnics plants follow strict safety rules. Workers operate in small crews, wear anti-static clothing, and handle only minimal amounts of mixture at any one time to reduce the risk of accidental explosions. Why are firecrackers so loud? This question comes up a lot. The deal is, a firecracker's explosion isn't just a chemical reaction. It's a massive release of energy in a confined space. When the powder burns, it releases hot gases that expand super fast, creating a powerful shockwave. And since the casing is tightly packed, that wave comes with the trademark boom sound we all know. The word firecracker comes from the French pétard, meaning a blast. Like fireworks, firecrackers trace their roots back to China. Initially, they were used to scare off evil spirits, and only later did they become a popular form of entertainment. Today, firecrackers are an essential part of many celebrations and festivals around the globe. But their history shows that even the simplest things can have deep roots and a fascinating evolution.
So, the next time you hear that familiar bang, remember just how much skill, history, and technique is packed into each tiny firecracker. When it comes to making fireworks, you also start by mixing gunpowder with other components. If you think of gunpowder as the engine of the firework, then the other materials are the artists who create that explosion of color, light, and shape. To get bright sparks, you need metal powders like aluminum, magnesium, and titanium shavings. For vivid colors, you rely on metal salts such as strontium, barium, copper, and sodium. To boost the energy of the blast, you add ingredients like potassium nitrate, perchlorates, and charcoal. These act as oxidizers and fuels. And to hold it all together, you use binding agents, like water-soluble glues. Each component is first ground into the finest possible powder. Picture shining metal particles dancing in the light as the master prepares them for blending. These powders are so lightweight, it's almost as if they're suspended in midair, like some kind of magical dust. The most important step starts when the ingredients go into a mill filled with ceramic or wooden balls. These balls rotate gently, grinding the mix into a perfectly uniform blend. There's a soft rustle and a light tapping sound, kind of a subtle rhythm, reminding you that a future burst of colors is being born. As for mixing the ingredients by hand, at traditional production sites, this step is done with great care and reverence. Specialists slowly and carefully blend the ingredients with wooden or copper paddles. Why so slow? Because even a single stray spark could set the whole thing off. The mixture looks like a shimmering sand, where each component has its role to play. To avoid accidental explosions, the mixture is often moistened. Water doesn't just make the process safer, it adds a sort of mysterious alchemy, as gunpowder and colorants form tiny granules. The smallest mistake can cause a tragedy. You know what pyrotechnic masters do before they start working? They remove all metal objects, even wedding rings, to prevent sparks. In many labs, cell phones are strictly forbidden, and employees wear anti-static clothing. Even the air matters. Conditions are kept humid enough so that mixes don't dry out and become dangerously volatile. Before packing the mixture into the casing, the masters test how it burns. A small sample is ignited, and everyone holds their breath. Is that the perfect shade of blue? Are the sparks bright enough? It's like a dress rehearsal before the big show. Creating shapes and colors. That's the coolest part of production. Want a heart or a star in the sky? It all depends on how the stars are arranged. These are tiny pellets with a special composition. Where'd those brilliant reds, greens, and blues come from? All thanks to chemical compounds. For instance, barium makes green, strontium makes red, and copper makes blue. Once all the components are prepped, the next crucial step is filling the casing, where the heart of the future firework is born. It's right here that the explosive mix and colorants become a finished product, capable of painting the night sky in every color of the rainbow. The casing is a shell that holds all the fireworks parts together. It's made from special materials that can handle high pressure and heat, yet remain light enough to shoot into the sky. Cylindrical shapes are perfect for forming sharp patterns like rings, chrysanthemums, or peonies, while spherical shells create symmetrical three-dimensional effects, like a glowing orb exploding into hundreds of sparks. The filling process is super important, because the exact placement of components ensures the desired effect. Let's break it down step by step. First, you take cylindrical or spherical shells, usually made of cardboard, plastic, or specially treated paper with fire-resistant properties. Spheres typically come in two halves that will be joined later. It's crucial that the casing is airtight. That guarantees the explosion happens at the right moment with the right intensity. The black powder charge, acting as the main engine, sits at the center. It's responsible for propelling the firework skyward and making sure it explodes properly. Around that charge, the colorants and special effect mixtures are arranged. Each tiny star element is placed by hand or using special machines. These stars are what we call the pellets that burn in the sky. For spherical shells, these stars are placed evenly, so that when it explodes, it forms a perfect sphere of light. In cylindrical shells, charges are often laid in layers or formed into specific patterns, depending on the planned effect. One standard spherical firework can hold about 200 to 300 pellets. Large, multi-layer shells might have over 1,000 of them. To ensure the firework explodes at the right time, a time delay fuse is added. A small tube filled with a slower burning composition. This timer connects to the main charge, providing a delay between the rocket's launch and the burst in the sky. After all elements are in place, they're secured with a special paste or paper spacers. This keeps every component locked in position during the launch. The casing might then be wound tightly with string or glued for extra rigidity. Crafting one large professional-grade firework can take up to 4 hours, considering all the careful assembly and testing. For a massive show with several thousand shells, pyrotechnicians might work for a few months straight. The spherical shape is the classic standard in pyrotechnics, giving an even spread of stars and creating that perfect circular effect. Filling such a shell requires even more skill. Each star is placed by hand around the central charge. It's all on the master's shoulders. How the components are arranged will define how the explosion looks. For example, to create a smiley face in the sky, the pellets are laid out in the shape of a face. When the powder ignites, those pellets spread out just right, forming the intended pattern. Every year, over 200,000 short tons of fireworks are produced worldwide. China is the leader here, accounting for about 90% of the global output. For major holidays, like Independence Day in the United States or New Year's Eve in Sydney, up to 10,000 separate fireworks might be launched in a single night. Such a display can last over 20 minutes and sometimes costs as much as $5 million. Despite the beauty of fireworks, safety stats are pretty alarming. In the United States each year, up to 10,000 injuries are reported due to improper use of pyrotechnics, with about 70% of the injured being young people under 20 years old.
Imagine this. Every year, more than 50 million drums are made around the world. But have you ever wondered how a piece of wood becomes a powerful instrument that sets the rhythm for music? From ancient shamanic rituals to modern rock arenas, drums have always been the heart of sound. To create the perfect drum, wood is dried for years, metal parts are crafted with jewelry-like precision, and membranes undergo special treatments. Today, we're going inside this process, step by step, from the lumber mill right onto the stage. The drum is one of the oldest musical instruments in the world. Its history stretches back at least 7,000 years, perhaps even more. The earliest drums were simple, animal skin stretched over wooden or clay bases. Over time, they evolved into the complex structures made from various materials that we see today. The oldest drums found by archaeologists date back to 5,000 years before Christ. They have been discovered in Africa, Mesopotamia, China, and Egypt. These early drums featured clay or wooden bodies with animal skin membranes stretched with ropes or glued on with resin. In shamanic rituals and religious ceremonies, drums were used to communicate with spirits. In ancient China and Egypt, drums coordinated armies on battlefields. In some African tribes, drums were even used to send messages over long distances. In the Middle Ages, drums became popular in Europe thanks to the Arabs, who brought them through Spain during the Muslim conquests. During this period, drums became integral to military music and later orchestras. A drum isn't just a chunk of wood or metal. Every part matters: the shell, the membrane, the hoops, bolts, and even the drumsticks. All these elements are crafted from carefully selected materials, and each affects how the instrument sounds. Wood used for drum shells must be properly dried, processed, assembled, and finished with lacquer. Metal parts are cast, polished, and protected against corrosion. The process is more complex than it first appears. Let's dive deeper into these details. Wooden drums have a special warmth to their sound. But as we said before, creating such a shell first requires carefully selecting, preparing, and drying the wood. The most popular choice for drum shells is maple. It produces a warm, balanced tone with excellent lows, mids, and highs, making it a staple in most studio and live drums. Birch provides a bright, aggressive sound, boosting the highs and lows, perfect for rock, metal, and live performances. Mahogany offers a deep, bass-rich sound with mellow highs, famously used in vintage drums from the 1950s and 1960s. Bobinga, a dense African hardwood, delivers a darker, powerful tone with great attack. More expensive, it's reserved for premium models. Oak, harder than maple, provides an exceptionally loud, penetrating sound ideal for live settings. Simply cutting down a tree and slicing it into boards is just the beginning. The tree must be harvested in a specific season, usually winter, when it contains the least moisture. Logs without cracks or knots are chosen. Freshly cut wood can have up to 60% moisture. First, the wood air dries outdoors for several months or even years. Then it undergoes kiln drying, reducing moisture content to between 8 and 12%. Next, boards are sliced into thin layers called plies, glued together under high pressure. The thickness of these wooden plies typically ranges from 0.024 inches to 0.118 inches. To produce uniform, thin layers without excess waste, several methods are used. Rotary cutting involves mounting logs onto special machines that spin them while blades peel thin, continuous wood strips, typically for budget drums.
Bandsawing uses a flexible, continuous saw blade, moving in a loop to cut logs into thin plies. This method provides more precise cuts than rotary peeling, and preserves the wood grain better, although it creates more waste. For high-end drums showcasing exotic wood grains, manufacturers employ veneer slicing. Logs or boards are fixed, then moved against a sharp blade to shave off thin sheets. Laser cutting is the least common method. Premium drums sometimes feature solid wood shells, providing unique tonal qualities. But today, we're not focusing on those. Let us know in the comments if you'd like a separate video dedicated to that topic. First, the plies are coated with special glue, then stacked, forming a multi-layered structure. The number of layers typically varies from 4 to 20, depending on the desired shell thickness. Next, this stack is placed into specialized molds, bending the wood into a perfectly round cylinder. Even pressure is crucial to prevent defects and air bubbles in the glue. Afterward, the shells dry for several hours or even days. Once the glue hardens, shells are removed, edges trimmed, sanded, and drilled for hardware. This method is economical and allows manufacturers to experiment with combinations of wood types to influence sound characteristics. Polishing and applying finishing coatings is primarily manual work, especially for high-quality or custom drums. Shell surfaces are carefully sanded, removing all irregularities. Sanding happens either by hand or machine, progressing from coarse to extremely fine abrasives, usually from 120 to 400 grit. For glossy lacquer finishes, manufacturers may first apply primer to prevent excessive absorption by wood pores. Oil or wax finishes are rubbed in manually using soft cloths or brushes, penetrating deeply into the wood pores, protecting from moisture and enhancing the natural color. Lacquer is sprayed in several thin layers, drying completely between each coat. This process is performed by skilled artisans manually or by automated equipment in large factories. After drying, shells receive a final polishing to achieve the desired gloss, ranging from matte to mirror-like shine. In large companies like Pearl or Yamaha, producing hundreds of drums, lacquer is applied automatically. Still, final finishing always occurs by hand, since even the best machines cannot match human precision. Boutique manufacturers such as Cravioto, Brady, or Noble & Cooley finish every shell entirely by hand, making each drum unique and even more expensive. Even wooden drum shells have numerous metal parts: hoops, tension rods, and grommets. Hoops are typically chrome-plated steel, brass, aluminum, or even wood. Tension rods are commonly stainless steel or brass. Grommets are small metal inserts reinforcing the drilled holes in the shell. How are metal parts produced? Metal is melted at high temperatures, then cast or machined into required shapes. These parts are sanded and polished, removing roughness, then coated with protective layers like chrome or nickel to prevent rust. Historically, drums featured animal skins: cow, goat, or buffalo.
Nowadays, synthetic plastics are more common due to their stability, durability, and weather resistance. Natural animal skin, being organic, expands and contracts with humidity and temperature changes. Moisture makes skins softer and sounds duller, whereas dry conditions cause them to shrink and crack. Synthetic materials maintain consistent tension regardless of weather. Once tuned, synthetic drumheads remain stable until manually adjusted. Drumhead materials, whether skins or plastic, are cut into circular pieces, treated chemically for flexibility, then pressed and stretched onto metal hoops. Preparing animal skins is truly spectacular. Inside large workshops, air smells of smoke, salt, and something sharp. Huge wooden vats line the walls, holding pieces of skin that visibly change color. This isn't mere soaking. It's true alchemy transforming tough, uneven hides into perfect drumheads. Initially, skins soak in large vats containing lime solutions, softening them and removing hair. After several hours or days, skins become lighter but still coarse. Next, they're treated with tanning substances, penetrating their structure on a molecular level. Vats emit steam. The aromas of wood, metal, and rawhide blend in the air. To avoid excessive stiffness, skins are stretched onto large wooden frames. Craftsmen stretch the skins manually, feeling thickness with their fingers. Sometimes steam is used, filling the workshop with thick vapor as skins are warmed before final treatment. Lastly, skins are rubbed with special mixtures, oils, waxes, sometimes herbal extracts. This keeps them flexible yet strong. In some regions, they're even smoked, imparting a light, smoky scent and improved water resistance. Even the best drum won't sound great without proper drumsticks. These are also crafted from carefully selected wood. Wood, typically hickory, maple, or oak, is sawn into blanks and air-dried naturally. But this takes time, so kilns usually speed the process, carefully controlling temperature and humidity, aiming for moisture content of 6 to 8%. Correct moisture levels are critical. Too moist, sticks warp. Too dry, they become brittle. Dried blanks are shaped on high-speed lathes. Each stick must have identical diameters. Otherwise, sticks within pairs produce different sounds. Simply turning a round stick isn't enough. Tip shape, taper in the middle, and weight distribution define how sticks sound when striking drums. High-speed lathes achieve precision within thousandths of an inch to ensure consistent quality. Every single day, more than 20 million banknotes are destroyed in the United States. That is a mountain of money that could reach the sky. But what exactly happens to them? Are they burned, shredded, or maybe turned into something completely unexpected? US dollars have their own life cycle, and their disposal is a high-security operation involving armored trucks, strict inspections, and secret routes. How do old banknotes disappear forever? And is there any way to save them? Let's find out. The dollar as a currency has a fascinating history. It all began in the mid-17th century. The first dollars appeared in the New England colonies in the year 1690, at a time when the United States did not yet have a unified national currency. Back then, the colonies issued their own money, and one of these was the so-called paper dollar. However, the true dollar as we know it today emerged later, in the year 1792, when the United States Congress passed the Coinage Act. This was the country's first attempt to introduce a single currency, establishing the dollar standard based on a silver coin. The dollar quickly became the main currency for trade and wealth accumulation, as the nation sought to create a stable and accessible monetary system that would support its economy and commercial ties. Today, the dollar has evolved into one of the world's leading currencies, used in international transactions across the globe. The idea of disposing of old banknotes arose at the beginning of modern financial systems, especially when currencies started to become standardized and central banks began managing the money supply. In other words, the process of removing worn-out dollars started as soon as money became a stable and regulated instrument, though it was not officially systematized until much later. The concept of destroying damaged money first appeared in Great Britain during the 19th century. When the British government realized that allowing worn-out banknotes or coins to remain in circulation reduced the overall value of the currency. However, the systematic destruction of money, as it is done today, only became possible with advancements in modern financial systems and technology. In the United States, the first efforts to manage old and worn-out dollars began in the mid-19th century, when the first central authorities responsible for currency emerged, and money became a key instrument of the national economy. In the year 1861, when the United States first introduced federal paper money, known as greenbacks, the need arose to organize their circulation, including their disposal. The official process of destroying old dollars was established by the Federal Reserve after its creation in the year 1913. The Federal Reserve became the primary institution responsible for regulating the money supply, including removing old banknotes from circulation. The idea of destroying old banknotes was first introduced by central banks, which discovered that worn-out and damaged money not only harmed the image of a national currency, but could also create economic problems. If old banknotes remained in circulation, it could destabilize the monetary system, increase the risk of counterfeiting, and even affect inflation rates. To prevent this, the Federal Reserve established a clear policy outlining when and how banknotes should be removed from circulation. This became an essential part of maintaining economic stability. So, what exactly happens to all the money that can no longer be used and that no one wants to see anymore? Are they just burned? Well, not exactly. Disposing of US dollars is a complex process that follows a highly regulated system, ensuring both destruction and security. Here's how it works. First of all, when money is removed from circulation, whether it is declared damaged or obsolete, it does not simply get thrown in the trash. Everything goes through the United States Federal Reserve System, which manages the issuance and renewal of dollars. They collect old banknotes and send them to specialized facilities for further disposal. When you or someone else brings damaged or worn-out dollars to a bank, that is where the process begins. Banks have strict procedures for identifying banknotes that are no longer fit for circulation. These banknotes are inspected both manually and automatically using specialized machines that detect damage, wear, or counterfeit signs. Modern ATMs and cash dispensers are also equipped with sensors to detect worn-out banknotes. If a bill is found to be damaged or degraded, it is usually placed into special compartments or sent to sorting machines in banks. Once a sufficient number of old banknotes accumulate in banks, they are sent to the next stage, the Federal Reserve. These are special facilities located across the country that inspect, replace, and dispose of currency. Several such centers exist across the United States, strategically positioned to efficiently serve all regions. The process of transporting old banknotes to the Federal Reserve or specialized disposal facilities is strictly regulated. Banks typically work with security firms specializing in transporting large sums of money. Old banknotes are packed into special bags or containers that are sealed and secured against unauthorized access. This is crucial because even old money remains a potential target for theft or counterfeiting if not handled properly. Security guards or specialized couriers deliver these packages to the Federal Reserve or disposal facilities. The transport companies involved in this process operate under the highest security standards, and shipments are often escorted by police or other security services when necessary. You would not believe how many old banknotes accumulate each year, and this applies not only to US dollars, but also to other currencies. Bank vaults are not limitless in space, so from time to time, large batches of worn-out bills must be removed. Every day, thousands of banknotes pass through people's hands. Some get crumpled, some get coffee spilled on them, and some even end up in the laundry. Add the natural wear and tear, and you have a massive pile of money that is no longer usable. Imagine this. Every single day, the United States Federal Reserve destroys millions of banknotes. If you stacked them up, they would reach as high as a skyscraper. And that is just in one day. Transporting such massive amounts requires trucks. Money is packed into special bags or boxes. Each container has a unique number and seal to ensure it remains unopened. And while these may no longer be real money in a traditional sense, they still hold value. So the security of such shipments is incredibly tight. It is almost like a scene from an action movie. Armored trucks, armed guards, secret routes. Except here, instead of a heist, the mission is to get rid of this money forever. A true financial thriller, right? Before the old banknotes are destroyed, they go through careful inspection. Special systems determine whether they can be reused. If a banknote still retains at least 50% of its original form, it can be reintroduced into circulation after a special treatment, such as reprocessing or trimming. This significantly reduces the cost of printing new banknotes. Every year, an enormous amount of old dollars is destroyed in the United States. For example, in the year 2020, around 7 billion banknotes were eliminated because they were too worn out to remain in circulation. This process is continuously maintained at the highest level to keep the currency stable. Some damaged banknotes are not immediately burned. Instead, they are recycled into other materials, such as fibers that are later used to produce new banknotes. This helps reduce production costs and support sustainability efforts. There is also an interesting psychological aspect to this process. For many people, destroying money might seem like a loss of value, but in reality, it is part of a continuous cycle that helps preserve the stability and worth of the currency. That is why this process is just as crucial as printing new money. Old US dollars are often destroyed in specialized incinerators or through processes that ensure maximum material utilization. Banknotes are burned at temperatures of approximately 2,000 degrees Fahrenheit, completely obliterating them. Furthermore, advanced filtration and technology capture toxic gases and other harmful byproducts to ensure safety during the process. But does it not feel strange to burn so much money? Given how much we spend daily, these sums seem enormous. However, the portion of money that gets destroyed is actually a tiny fraction of the total circulating supply. In the end, the system is highly reliable and efficient. After the banknotes are burned, tons of ash remain. Some companies repurpose this ash into materials for making compost or even bricks. This part fascinates me. Dollars get reborn and continue serving humanity in new ways.
Have you ever wondered how the beer you drink is made? Imagine this: 1 million tons of grain every year, thousands of bottles filled every minute, and automated machines working with millimeter precision. We are diving into the world of brewing at the Anheuser-Busch factory, the largest beer producer in the world. We will discover how ordinary barley transforms into a hoppy beverage and why every drop of Budweiser undergoes meticulous quality control. This is not just production. It is a spectacle of scale, flavor, and innovation that you absolutely will not want to miss.
Did you know that the average American drinks about 2,500 ounces of beer annually? And while the Czech Republic and Germany lead in beer consumption, Anheuser-Busch supplies a significant portion of the global demand. It all begins with humble barley. At the factory, I witnessed how tons of grain are delivered and processed before being turned into malt, one of beer's main ingredients. Everything here is automated. Specialized machines grind the grain and soak it in water to wake up the enzymes. It literally looks like a dance of machinery, with each piece knowing its role precisely. In enormous steel tanks as tall as a 3-story building, giant machines load tons of golden barley. You can hear the soft, calming sound of the grain cascading downward, reminiscent of gentle rain. What happens next is pure technological magic. Special machines delicately grind the grain, exposing its core, starch. It looks as though the grain passes through a massive waterfall, transforming into a light, fluffy powder. This powder then ends up in enormous vats filled with warm water. Here is an interesting fact. The machines do not simply soak the grain in water. They maintain an ideal temperature and humidity level, like a steam bath designed to activate the enzymes. You can see the vats come alive with hot steam passing through them. Water mixes with the ground grain, forming a thick, creamy mixture that begins to release the aroma of freshly baked bread. This moment feels incredibly vivid. It is as if the grain awakens and starts working together with this mechanical orchestra. The malt vat begins to rotate. Yes, it does not just sit still. It practically dances, with special paddles mixing the blend so the enzymes activate evenly. Steam rises, forming a light mist that fills the room with a sweet aroma. Sometimes this steam is lit with special lamps, adding a touch of spectacle.
as if you are witnessing a scene from a sci-fi movie. And this is only the beginning. The porridge then passes through other tanks equipped with precise filters that separate the liquid, the malt extract, from the leftover grain. Now imagine this happening on a scale where a single processing cycle can fill thousands of bottles of beer. This is not just production, it is a full-scale performance. The machines operate with the precision of fine jewelry, and as you stand nearby, you feel like a witness to something monumental. The entire process is filled with rhythm, aromas, and sights that will make you forever respect beer. Though, to be honest, I already respect beer because it sponsors my enjoyable Friday nights. Anheuser-Busch sources barley from various farms, and the quality is scrutinized down to the smallest detail. Different beers require different malts. Lager? A light malt base is needed. Stout? Add darker, roasted malt. You get the idea. They use around 1 million tons of grain annually for beer production. Now for the most exciting part. These giant steel fermentation tanks are so enormous that it feels like you could fit an entire football team inside one. This is where the magic begins. Maltwort, a sweet liquid extracted from the grain, is mixed with hops and yeast. Honestly, the smell in the fermentation hall is something else. It is a warm, rich aroma reminiscent of bread and fruits. The yeast here works like crazy, turning sugar into alcohol and carbon dioxide. Fermentation lasts anywhere from several days to a few weeks, depending on the type of beer. The factory employs about 4,000 people. It is like a small town. But what surprised me the most is the level of automation. People here mostly monitor the process from screens while the machines handle the bulk of the work. Even the smallest details, like the temperature and pressure inside the tanks, are controlled by computers. Honestly, the factory feels more like a scientific laboratory than a traditional brewery. And it did not start out this technologically advanced. Anheuser-Busch has an incredibly fascinating history. It all began in the year 1852, when a small brewery opened in St. Louis, simply called Bavarian Brewery. In the 1860s, it was purchased by Eberhard Anheuser, a German immigrant, and his son-in-law, Adolphus Busch, joined the business a few years later. That is when the real boom began. Adolphus Busch was not just an entrepreneur, but an innovator. Imagine this. In the year 1876, they created Budweiser, the first American lager beer. To make it accessible anywhere in the United States, Busch introduced revolutionary transportation methods, such as refrigerated rail cars. This was a game changer for the beer industry. Today, Anheuser-Busch is part of the AB InBev Corporation, the largest beer producer in the world. Their brands, Budweiser, Michelob, Stella Artois, Corona, are recognized on every continent. According to AB InBev, Budweiser alone is sold in over 85 countries, producing over 2,064 million gallons of beer annually. On average, each production line fills 1,500 bottles or cans per minute. The bottling line is a true showcase of technical perfection. Hundreds of cans and bottles flow in rapid streams, perfectly aligned, gleaming under bright lights. The entire process is fully automated, and watching it is like observing a finely tuned clock mechanism, but on an enormous scale. First, empty bottles or cans enter the conveyor. They are thoroughly washed to remove even the tiniest specks of dust, because cleanliness here is paramount. Machines spin each container under spiral nozzles that shower them with jets of water. Next comes the filling stage. Cans line up under high-precision dispensers that pour the exact amount of beer into each one in mere fractions of a second. Interestingly, this happens in near-vacuum conditions. Why? To prevent foam formation and avoid any contact between the beer and oxygen, as this could affect its flavor. The next step is sealing. Caps for bottles or lids for cans are fed onto the conveyor through a separate line, and special automatic clamps secure them with such speed that it is almost impossible to see the movement with the naked eye. Then comes the packaging. This is where the real conveyor magic happens. Bottles, cans, kegs, everything moves at lightning speed. More than 1,500 bottles are filled and sealed every minute. Watch this rhythm. Every can undergoes a seal test before moving on to packaging. Here is another interesting detail. Bottle coloring and label printing are also automated. Conveyors move, machines blink, and staff only occasionally intervene to ensure everything runs smoothly. Overall, lasers, sensors, and cameras at every stage ensure quality control. If even a single can or bottle fails to meet standards, the machine instantly removes it from the line. This guarantees that only the best product reaches consumers. Despite the scale of production, the taste of the beer remains consistent. That is their top priority. Every batch undergoes tasting before hitting the shelves. And trust me, this is not just a formality. The tasters here work at the level of true sommeliers. And this is just one factory in the Anheuser-Busch network. In total, the company operates 12 breweries in the United States, along with over 20 distribution centers. Another thing that impressed me, Anheuser-Busch actively works to reduce its environmental impact. For instance, the water used in brewing is purified and reused, and all waste, such as grain husks, is sent to farms as livestock feed. You can now tell your spouse, "Honey, I am not just drinking beer, I am supporting cattle feed in the United States. If you survive saying that, let me know how it goes." Although their largest factories are in the United States, the company has facilities on every continent except Antarctica. By the way, the factory in St. Louis is also a tourist attraction. Every year, they host tours for tens of thousands of visitors. Guests are taken to historic production halls, shown giant tanks, and even get to see their famous Clydesdale horses. And if you are wondering whether you can taste the beer, of course. At the end of each tour, guests are invited to a tasting room to sample the freshest beer. Anheuser-Busch is not just a company, it is a living history of innovation, scale, and tradition. They started as a small brewery in St. Louis and have grown into a giant that is reshaping the beer industry. Next time you open a bottle of Budweiser or Michelob, remember these numbers, this scale, and the people behind every drop of beer. One factory, 1 million chickens, over 500,000 eggs every single day, and roughly 120 tons of feed. Imagine that. Automated systems handle feeding, sorting, and packaging to keep this process running non-stop. Every day, these chickens drink enough water to fill 29 Olympic-sized swimming pools. Modern tech makes it possible for a chicken metropolis to run with just about 100 workers. How is that even possible? You'll find out in our video. Chickens on large farms are kept either in cages or in free-range systems. If they're in cages, these are arranged in multi-level rows. Think of it like a chicken skyscraper. Each cage has everything a chicken needs: perches, feeders, drinkers, and even a sloped floor so eggs roll straight into a collection tray after being laid. On the other hand, free-range chickens have more space to roam. They get access to the outdoors, though it's usually not a lush green field, but specially designed enclosed areas. Even in these systems, everything is organized down to the smallest detail. This factory houses 1 million chickens in a caged system, covering over 25 acres. By comparison, the same number of birds in a free-range system would need more than 80 acres. Here's another fascinating fact. Modern farms maximize vertical space, especially in caged systems, to optimize efficiency. Most of the area is used for multi-level production facilities, housing cages, feed silos, sorting rooms, and staff areas. The chickens are fed specially formulated feed to ensure consistent egg production. This feed is a mix of grains, corn, soybeans, and added vitamins and minerals. And here's the kicker. Every single gram of feed is crucial because it determines the quality and quantity of the eggs. Feed is constantly tested for protein, calcium, and potential contaminants. Some farms even add herbal extracts to keep the chickens healthy without antibiotics. Large farms use automated feeding systems. Feed is distributed through pipes or conveyor belts, filling feeders in the cages or barns. Sensors monitor feed levels and automatically dispense more when needed. Chickens receive feed tailored to their stage of life. Young chicks get starter feed rich in protein and energy. Layers receive feed high in calcium, vitamins, and trace minerals for strong eggshells. Chickens nearing the end of their life cycle get finisher feed. The feed also includes additives to support digestive health, boost immunity, and improve egg quality. Chickens are fed 2 to 4 times daily, depending on the system.
Some farms schedule feedings right before laying time to encourage consistent egg production. Layers consume about 5 ounces of feed daily. For 1 million chickens, that's nearly 120 tons of feed every day, or about 40,000 tons annually. Just look at the massive silos and transportation systems needed to manage that volume. In addition to feed, chickens are provided with clean drinking water. Nipple drinkers allow them to drink without spilling. 1 million chickens require over 2.5 million gallons of water annually, roughly the amount held by 29 Olympic-sized swimming pools. Feed is stored in silos, protected from moisture and mold. Its nutritional content is constantly analyzed to ensure quality. Modern farms even use software to track how much feed each group of chickens consumes. In some free-range systems, chickens are also allowed to forage for grass, insects, and grains, making their diet more natural. But even here, the primary feed is delivered automatically. Feeding systems are key to ensuring chickens lay eggs consistently and stay healthy throughout their production cycle. After laying, eggs roll into trays through special chutes. From there, they're transported on conveyor belts. Imagine an endless line of eggs floating towards sorting machines. These machines check for defects, discarding damaged or undersized eggs using special scanners that literally illuminate the eggs. It's futuristic. Before packaging, eggs are carefully washed in warm water with gentle disinfectants. This step ensures their safety. And no, it's not just a quick rinse. Eggs go through several warm water baths to remove dirt and microorganisms. Then they're dried and coated with a thin layer of food-grade wax for protection. At the sorting stage, each egg is weighed and categorized: large, medium, and so on. Depending on the category, eggs are packed into boxes. Simultaneously, shells are dried to prevent moisture that could lead to bacterial growth. Clean inspected eggs are placed in cartons or plastic trays by automated arms. Packaging includes details like packing date, grade, size, and producer certification. Storing such a daily volume of eggs requires refrigerators with over 70,000 cubic feet of capacity, about 40 large refrigerated trucks. After packaging, eggs are sent to storage facilities or logistics centers. Here, strict temperature controls between 32 and 40 degrees Fahrenheit keep them fresh. Eggs are transported in refrigerated trucks to prevent spoilage. At distribution centers, eggs are sorted based on supermarket orders and quickly delivered to stores or markets. Modern logistics systems reduce the time from farm to shelf to just a few days. Once on supermarket shelves, eggs are stored in refrigerators to maintain freshness. Consistent storage temperatures are crucial because sudden changes can cause condensation, increasing the risk of shell contamination. Consumers choose eggs based on size, price, brand, or labels like organic or free range. At home, eggs are stored in the fridge. Freshness is easy to check. If an egg sinks in water, it's good to use. Although large-scale farms are resource-intensive, many are adopting eco-friendly initiatives. These efforts not only reduce environmental impact, but also meet growing consumer demand for sustainable products. Some farms invest in solar panels on facility roofs or nearby solar fields, covering 30 to 50% of their energy needs. Chicken manure, a natural byproduct of any farm, is a valuable resource for agriculture. Chickens produce as much manure as the feed they consume, over 100 tons daily. Manure is collected, dried, and processed into organic fertilizer. Instead of creating waste, farms provide a product that restores soil fertility and reduces reliance on chemical fertilizers. Fertilizer production from chicken manure also lowers methane emissions compared to natural decomposition. Did you know a single chicken lays 1 egg a day? Of course, 1 million chickens don't equal 1 million eggs daily, since some aren't laying yet or have stopped laying. Still, production numbers are impressive. Over 500,000 eggs each day. Stack those eggs, and you'd get a column over 29,500 feet tall, 23 times higher than the orbit of the International Space Station. Younger chickens lay eggs almost daily, while older ones do so less frequently. Balanced feed helps boost egg production. Factors like temperature,
lighting, and stress-free conditions also play a big role. During winter, shorter daylight hours can slightly reduce laying rates. American eggs are rich in protein, vitamins D and B12, iron, and other nutrients. There are even eggs with higher omega-3 content, depending on the chicken's diet. You know what surprised me the most? The small workforce. Modern automation allows a 1 million chicken farm to operate with just 100 or so workers. Their tasks include equipment monitoring, veterinary care, and managing feed and egg logistics. A farm of this size can generate up to $50 million in annual revenue. This makes a significant contribution to the local economy, especially in logistics, feed production, and processing. These numbers show just how massive and coordinated the effort is to keep a steady flow of eggs heading to stores and ultimately to our kitchens. Have you ever wondered how many times aluminum can be recycled? Imagine this. One can you drank from today could be back on the shelf as a brand new can in just 60 days. And here's a jaw-dropper. Over 120,000 aluminum cans are used every minute worldwide. But wait, there's more. In the United States alone, enough cans are recycled each year to cover 3,000 football fields. Why is recycling aluminum so critical? How do these tiny metal heroes make such a massive impact on the planet? Let's dive into this video where every statistic amazes, and the transformation process will leave you inspired. The journey of recycling aluminum cans starts with collection, a crucial step in the recycling chain because timely gathering of raw materials ensures efficient processing later on. Most aluminum cans are collected through specialized waste collection systems in cities and communities. Many countries have waste sorting programs encouraging consumers to deposit empty cans in dedicated metal recycling bins. In the United States, there are widespread redemption centers where consumers can return used cans for a small cash reward or discount, incentivizing eco-friendly behavior. These programs are also common in parts of Europe and Australia. Some regions even organize campaigns where individuals can bring used cans to special recycling stations, making it easier to gather metal waste while reducing environmental pollution. Globally, about 120,000 aluminum cans are used every single minute, a staggering number that highlights the importance of efficient recycling. Many stores feature special bins for collecting empty aluminum cans, especially in areas with popular deposit systems, where consumers can return packaging for a refund, often earning a few cents for each can. Beverage manufacturers and packaging companies also participate in the recycling process by sending metal waste from production to collection centers. This applies to used cans and leftover aluminum elements from the manufacturing process. Some recycling systems even include automatic waste sorting at the collection stage. Advanced technologies like magnetic separators are used to extract aluminum from other metals and plastics efficiently. In regions without such systems, manual sorting is still the norm. In the United States, the aluminum can recycling market is valued at over $1 billion annually. This massive industry injects revenue back into the economy, fueling businesses that recycle and produce new products from repurposed metal. Once collected and sorted, the cans are transported to a recycling facility, where they're stored in massive containers or warehouses until processing begins. The entire recycling journey of an aluminum can take less than 60 days, from the moment it arrives at the facility to the moment it's transformed into a brand new product. That means the can you finished today could be back on the shelf in just 2 months. To ensure a smooth process, cans must be kept separate from other waste materials, so they're often stored separately. Before moving on to further processing, the cans undergo a thorough cleaning. This includes washing off any leftover liquids, removing labels, adhesives, and other contaminants that might still be on the packaging. And now for the most epic part, shredding. Once cleaned, the cans are shredded into small pieces using industrial shredders or other mechanical equipment. This step drastically reduces the volume of the material, making it easier to process. What's left are aluminum shreds, or chunks, ready to be transformed into new products. I've got to say, being there for this part was nerve-wracking. It felt like one of those shards might fly off and hit me in the eye. And the noise, the grinding and crunching were absolutely deafening. hot. Insanely, blisteringly hot. That's how it felt when we approached the smelting furnace. The shredded aluminum pieces are sent straight into it. 1,220 degrees Fahrenheit, a temperature so intense, it's surprising it's not 1,222 for some devilish symmetry. Melting is the key stage where the metal is heated until it turns liquid. During this process, any remaining impurities and other materials are burned away, leaving behind pure aluminum ready for reuse. Watching it felt like witnessing the Terminator's final moments. I swear. The team explained to me that smelting is energy intensive, but even with the high energy consumption, this process is far more efficient and less costly than extracting virgin aluminum from ore.
The molten aluminum from the furnace is poured into molds to create ingots, wire rods, or sheet metal. These aluminum ingots, known as slabs, are massive blocks that are easy to handle during later processing stages. Each slab measures several yards in length and about 2 feet thick. Once cooled and solidified, this metal is ready for a new life, whether as fresh aluminum cans, car parts, construction materials, or other products. Here's the incredible part. This process can be repeated endlessly. Aluminum can be recycled over and over without losing its quality. Imagine that. Cans can go through the recycling loop dozens, even hundreds of times. It doesn't wear out from remelting. Honestly, it feels like we were lied to. Terminator had to be made of aluminum, folks.
Now, what are these wire rods, you ask? Fair question, and I've got the answer for you. Wire rods are a form of aluminum created after the molten metal is poured and shaped into thin wires or rods. After smelting, the liquid aluminum is cast into molds for further processing. The metal is rolled into large wire rods using specialized rolling mills. These mills reduce the cross-section of the metal and shape it into the desired form by passing it through rollers. The rods can then be cut into smaller sections or sent off for additional processing to create a variety of aluminum products.
In the end, wire rods are the foundational form of aluminum used to manufacture new products. This keeps the recycling and reuse cycle going strong. The diameter of aluminum rods can vary depending on their intended purpose, typically ranging from 0.04 of an inch to 0.75 of an inch. However, this can change based on production specifications and the final application. Thin wire rods, with a diameter ranging from 0.04 to 1/10 of an inch, are commonly used to make wires, electrical cables, or delicate metal components. Medium wire rods, measuring 1/16 to 0.4 of an inch, are suitable for sturdier products like structural elements or, in some cases, new aluminum cans, when further processing requires that specific diameter. Thick wire rods, over 0.4 of an inch in diameter, are reserved for heavy-duty applications such as the automotive industry or the production of large structural components. Each type of wire rod has its own specifications and undergoes additional processing depending on the final aluminum product being manufactured. To produce aluminum sheets, the slabs are gently heated and passed through powerful rolling mills that flatten them into thin sheets. At this stage, the sheets measure about 1/4 to 2/5 of an inch thick, but they're still too thick for most applications. After hot rolling, the sheets are cooled to stabilize their structure. If needed, they undergo annealing, a controlled process of heating and slow cooling, to relieve internal stress and improve the metal's flexibility. For ultra-thin sheets, like foil or packaging materials, the aluminum goes through cold rolling, reducing its thickness to less than 0.04 of an inch. This precision ensures the sheets meet the requirements for various specialized applications. Once the aluminum is formed into the required shape, whether as wire rods or sheets, it's transported to factories or directly to customers for further use in manufacturing. Recycling aluminum requires significantly less energy compared to extracting new material from ore. In fact, recycling aluminum saves up to 95% of the energy that would otherwise be needed for mining and processing raw aluminum. To put it into perspective, it's like a 100-watt light bulb running for 4 hours. Here's another mind-blowing stat. If all the aluminum cans recycled in the United States each year were stacked end-to-end, they'd cover approximately 3,000 football fields. And if you combined the recycled cans from the US and Europe, they could wrap around the Earth twice.
Imagine this. Every minute, over 70,000 Oreo cookies are sold worldwide. That's enough to circle the Earth more than 400 times. But what makes them so insanely popular? How do they create that legendary flavor and perfect texture, loved in over 100 countries? Today, we're stepping behind the scenes at one of the world's most famous factories to uncover all the secrets behind this iconic cookie. From its unique design to the creamy filling, let's dive in.
The Oreo recipe was first created back in 1912 at a factory in Manhattan. To this day, it remains the most popular cookie in the world. Since its inception, more than 500 billion Oreos have been sold. If you lined them all up, they'd wrap around the Earth over 400 times. Oreo is also one of the most active brands on social media, with over 40 million followers on Facebook and millions of fans on TikTok and Instagram. Campaigns like Twist, Lick, Dunk have gone viral in countless countries. It all begins with high-quality ingredients. Oreo uses premium-grade flour, cocoa powder, sugar, vegetable oils, and a secret blend of flavorings that make every batch unmistakable. But let's face it, ingredients alone aren't magic. They're mixed in precise proportions to form the base for the cookies. Inside the factory, massive mixers, capable of handling hundreds of pounds of dough at a time, work like a culinary orchestra, fast yet precise. Here's where the first secret lies: the cocoa. Oreo uses a specially processed cocoa powder that gives the cookies their rich, deep black color. And no, that shade isn't just from the chocolate. It's the result of a meticulously fine-tuned chemical process. Once the dough is ready, it's time to shape the cookies. This is where a high-tech conveyor system with custom molds steps into action. Yep, every Oreo cookie features a unique pattern, and it's not just for decoration. Each cookie's design is perfectly symmetrical, with 12 flowers, 12 dots, and 90 ridges around the edge. This iconic design hasn't changed since 1952, the year of its one and only redesign. The texture plays a big role in the overall taste experience. The smooth edges hold the cream in place, while the tiny, puzzle-like details add that signature crunch. Here's a fun fact. The machine that stamps the cookies can churn out up to 3,000 pieces per minute. Imagine that pace. Every single detail has to be flawless. Baking Oreos is a true science. The dough travels through an oven line that stretches up to 245 feet long, with the temperature monitored literally at every inch. First, a high temperature helps the cookie hold its shape, and then it's gradually reduced to prevent overdrying. The result? That perfect balance of a tender texture that melts in your mouth while staying satisfyingly crunchy with every bite. Now, let's move on to the filling. The cream for Oreos is made separately, and this process? It's nothing short of modern-day alchemy. Massive mixers whip the cream filling to the perfect consistency you know and love. Here's a little secret. The cream isn't just spread on. It's piped through special rotating nozzles to ensure an even layer. For the classic Oreo, that's a vanilla cream filling. But you already know how many flavors are out there today, right? From strawberry to mint chocolate, each new flavor undergoes rigorous testing before hitting store shelves. The formula for Oreo's cream filling is top secret, with only a handful of people in the world knowing the exact recipe. Now comes the most magical part: joining the two cookie halves. This process, called sandwiching, is performed with incredible precision by machines. Fun fact: every other cookie half is flipped upside down to ensure a smooth connection with the cream. And just like that, in seconds, the iconic sandwich is born, ready to enjoy. Studies show that around 50% of people twist apart their Oreos before eating them. Even more folks dip them in milk. In fact, Oreo is officially considered the perfect cookie for milk. Scientists have even experimented to find the optimal dunk time: 4 seconds. That's just long enough for the cookie to maintain its crunch while melting in your mouth. Every hour, over 1.5 million Oreos are produced in factories worldwide. Once the cookies are ready, they're sorted and sent to the packaging line. Quality checks happen every single time. And yes, there are imperfect cookies. They're sorted out and sent for recycling. Curious?
How Oreo stays so fresh in its packaging. It's all thanks to vacuum sealing. The packaging is specifically designed to preserve texture and flavor. It's made of multi-layered materials that keep out moisture and air, ensuring the cookies stay crispy. The outer layer of polypropylene provides durability, while the inner layer creates a barrier to protect against oxidation. The key to Oreo's packaging is the vacuum seal. Once the cookies are packed, excess air is removed from inside the bag to eliminate contact with oxygen. This keeps the cookies fresh for up to 9 months, or even longer. Each package is precisely cut to size using high-precision lasers, guaranteeing an airtight seal. You've probably noticed how easy it is to open modern Oreo packages. That's thanks to the peel and reseal closure, which allows you to open and close the package multiple times. This way, the cookies stay fresh even after the first opening. Oreo offers a wide range of packaging options so everyone can find their perfect fit. Standard packs, a classic for the home. Mini Oreos, small, snack-sized packs perfect for on-the-go munching. Mega packs, ideal for those who just can't get enough. And let's not forget individual packs of 2 or 3 cookies. Super convenient for the office or a lunchbox. That iconic blue packaging? It's no accident. The color is associated with freshness, lightness, and happy emotions. Each pack features a photo of the cookie with milk, sparking instant cravings. In some countries, Oreo even includes interactive packaging with QR codes, leading to games, recipes, or videos, adding an extra layer of fun. Recently, Oreo has been working hard to make its packaging more eco-friendly. In 2023, the company began testing recyclable materials for its packs, aiming to reduce the carbon footprint of production. In some countries, fully recyclable packaging is already in use. After packaging, the packs go through special scanners to check for weight and airtight seals. If even the smallest defect is found, the package is pulled from the line. Oreo uses specialized refrigerated containers during transportation to prevent temperature fluctuations. This ensures the filling's texture and the cookie's crunchiness are perfectly preserved. Did you know Oreo is made in over 50 countries and sold in more than 100? Every day, more than 40 million cookies are produced. That's more than the population of some countries. Interestingly, recipes and flavors can vary by region. For example, green tea flavor is a hit in China, while caramel fillings are a favorite in Latin America. Oreo has even been to space. In 2021, the brand sent its cookies to the International Space Station as part of a promotional campaign. And back in 1992, musician Weird Al Yankovic released a song called The White Stuff, a parody of New Kids on the Block's The Right Stuff. The song? A hilarious ode to the creamy filling of Oreo cookies. One of the most creative and fun marketing initiatives by Oreo is the Oreo Stacking Championship. The rules are simple. Participants compete to see who can build the tallest tower of Oreo cookies before it topples. But like everything Oreo touches, this competition transforms into a full-blown event, complete with heroes, records, and even a little drama. The current world record for stacking Oreo cookies stands at 54 cookies in a single tower. This record was set back in 2018 by an American at a local festival in Texas. Typically, records in these competitions range between 30 and 50 cookies because each additional layer makes balancing the structure even harder. Thanks to the cookie's round shape, towers often collapse at the most nerve-wracking moment, when someone tries to add that final cookie. It's all in good fun though, and the laughter from the audience and participants is infectious. At one championship in Japan, the winner was an 85-year-old grandma. She credited her victory to age bringing calm and patience. Oreo is officially recognized as the most popular cookie in the world, outselling all competitors in the cookie and dessert category. What makes Oreo so special? It's not just the flavor and texture, it's the emotions they spark. Admit it, you twist the cookie apart before eating it, right? Or maybe you dip it in milk. In the US, there's a cult-followed ritual for eating Oreos. Twist, lick, dunk. The process involves separating the cookie, licking off the cream, and dunking the rest in milk. Interestingly, women are more likely than men to take their Oreos apart before eating. It's this simplicity and versatility that have made Oreo a favorite for millions. It's a cookie that brings people together because everyone finds their own way to enjoy it. Every year, the world produces over 420,000 tons of snails. That's more than the weight of 300,000 cars. Imagine these slow creatures being transformed into delicacies worth up to 50 euros per kilogram, or their slime being used in cosmetics priced at up to 300 euros a jar. Snail farming isn't just a business, it's a billion-dollar industry. Want to know all the secrets? Stick around till the end. Picture vast fields where thousands of tiny snails crawl slowly among the greenery. These are snail farms, and they're more than just a thing. They're a serious business. Europe leads the world in snail farming, with most farms located in France, Italy, Spain, and Poland. The main species grown here are the Helix aspersa, or small gray snail, and Helix pomatia, known as the Burgundy snail. The idea of farming snails has ancient roots, dating back to ancient Rome. Think about it. The Romans were both gourmets and innovators. They were the first to cultivate snails on a large scale for food. How did it work? Romans built special snail gardens where they kept snails, feeding them herbs, fruits, and even wine. Yes, you read that right. They literally soaked snails in wine to make them more tender and flavorful.
The famous Roman naturalist Pliny the Elder, who lived in the 1st century AD, wrote about snails being a delicacy at noble banquets. He even mentioned a Roman gourmet, Quintus Fulvius Lupinus, who established the first known snail farm in the 1st century BC. After the fall of the Roman Empire, snail farming was somewhat forgotten. But during medieval times, monks revived it. For them, snails were a convenient food option during Lent, as they weren't officially considered meat. Clever monks, huh? By the 19th century, snail farms gained popularity in France and Italy, where modern farming methods were developed. The French were the first to turn snails into a gastronomic brand now known as escargot. In the 20th century, snail consumption increased so much that industrial-scale farms became necessary. Today, we have entire industries, from food to cosmetics, all thanks to this ancient Roman idea. Isn't that fascinating? Every year, over 420,000 tons of snails are farmed globally, with Europe dominating the market. France, for instance, consumes about 30,000 tons of snails annually, half of which are imported. Imagine the scale. Let's start with the snail nursery. Farms begin by collecting snail eggs, those tiny white pearl-like balls. The eggs are carefully selected because the farm's success depends on their quality. To encourage breeding, farms create specific conditions. The air temperature must be around 70 degrees Fahrenheit, with nearly 100% humidity. It's like a paradise for snails. Farmers even use special systems to keep the air moist, ensuring the snail's comfort. The eggs are then moved to incubators, where tiny snails hatch a few weeks later, barely recognizable as the future delicacies. Surprising, isn't it? My friend once had pet snails, and they bred like crazy in any conditions. But here, with all this care, there are no guarantees. Perfection is truly the enemy of good enough. Let's take a closer look at how snails grow. Once they hatch, the snails are moved to open enclosures, special fenced areas on the farm where they can crawl freely. They're fed a mix of grains and vegetables like cabbage, carrots, or even lettuce. Snail care is a science. Farmers regularly check their health, provide plenty of water, and even protect them from natural predators like birds or insects. Fun fact: a snail can drink more water than its body weight. In some countries, snail farms play relaxing music to reduce stress. Snails can take up to 6 months to grow large enough for harvest. Their size and weight depend on the species and farming conditions. Harvesting snails is an art. When snails reach the right size, they are collected, often by hand. Each snail is carefully inspected to ensure it's healthy and high quality. In snail farming, healthy and high quality involves several key factors: physical condition, suitability for consumption, or cosmetic use. A healthy snail actively moves, stretches its body, and responds quickly to stimuli like touch. Sluggish or closed snails might be stressed or sick. Their shells must be intact, free of cracks, spots, or chips, a sign of sufficient calcium in their diet. Healthy snails should also show no signs of parasites, fungal infections, or diseases that could affect their viability. On average, a snail weighs about 1 pound, though the ideal weight varies by species. This is the optimal size for culinary use. Before processing, snails are kept without food for 3 to 5 days to clear their digestive systems, ensuring the product is safe. A snail's diet impacts the quality of its meat, so their meals consist of greens, fruits, and special mixes. High-quality snails have tender, slightly sweet meat. They must be raised without harmful pesticides or fertilizers, as they are highly sensitive to contamination. For cosmetic purposes, snails need to produce a sufficient amount of slime, known as mucin. But more on that later. This requires proper nutrition and farming conditions. Healthy snail slime is transparent, impurity-free, and rich in beneficial components like allantoin, elastin, collagen, and vitamins. Quality snails live for 3 to 5 years, which is crucial for sustainable production. However, on farms, they're usually kept for about 14 months. Modern snail farming emphasizes eco-friendly practices, no soil or water contamination, and an organic approach to feeding. A healthy, high-quality snail grows in ideal conditions, eats a balanced diet, and shows no signs of stress or illness. It's perfect for gourmet dishes or premium cosmetics. Collected snails are washed and sent for further processing. If the farm caters to the restaurant market, the snails are immediately placed in special refrigerators, where they enter a state of dormancy, a natural process allowing them to sleep. Globally, over 420,000 tons of snails are farmed each year, with France, Italy, Spain, and Greece being major producers. Snails move at less than half a pound per second, so to cross a football field, they'd need about 5 hours. But they can endure a 2-hour walk in the rain without a break, the equivalent of a marathon for us. An average farm raises anywhere from 100,000 to 1 million snails. Now, the exciting part. How do these slow creatures become delicacies? First, they're prepped for consumption, washed, cleaned, and boiled. Then, they're marinated, baked, or stuffed with delicious sauces. Did you know French restaurants love serving snails in their shells with a garlic butter sauce? It's their signature move. If food is clear, how did snails end up in cosmetics? It's all about the slime. It contains beneficial substances like allantoin, collagen, and glycolic acid that work wonders on the skin. In ancient Rome, slaves rubbed snail slime on their mistress's skin, believing it healed wounds and rejuvenated. In the 1980s, Chilean farmers raising snails for export noticed their hands became unusually soft, free of cuts or scars. This sparked the idea of using mucin in cosmetics. On specialized farms, snails are kept in comfortable conditions where they produce slime. This slime is harvested without harming the animals and used in creams, masks, and serums. They say this ingredient works miracles, rejuvenating skin and addressing imperfections. The snail slime cosmetics industry is worth $760 million and grows 10% annually. The biggest buyer, South Korea. The slime collection process may seem odd, but it's designed to be cruelty-free. There are 2 methods: manual stimulation and automated systems. In manual stimulation, farmers gently massage the snail's body or spray it with clean water and sea salt. The snail secretes slime as a natural defense mechanism. The collected slime is washed and sent for filtration. For automated systems, large farms use special devices. Snails are placed in containers where they are gently stimulated with water or air streams. The slime flows into a reservoir for collection. Afterward, the snails are washed and returned to their enclosures.
They can produce slime again after a few days, ensuring the process doesn't harm them. The collected slime is purified, leaving only the valuable components. The resulting mucin is rich in collagen, elastin, glycoproteins, and other active ingredients. After processing, the slime becomes a raw material for cosmetics or pharmaceuticals. Snail slime is then used in high-end creams and serums that repair skin and treat acne. To produce 33 ounces of quality mucin, about 50,000 snails are needed. The snail market isn't just about food or cosmetics. In the European Union alone, it's a multi-billion euro business. 1 kilogram of snails can cost between 20 and 50 euros, depending on their origin and processing. Cosmetic products made from snail slime sell for 30 to 300 euros per jar. What do a sandwich, potato wedges, and pasta have in common? That's right, cheese. It takes these simple dishes and turns them into pure bliss. There are plenty of cheeses in the world, but cheddar holds a special place in my heart. Today we're diving into my love story with this cheese, my go-to for the easiest, most delicious meals I know. Let's get started. At the cheese factory where cheddar is made, pasteurization is like a technological dance. By the way, are you into techno? The process kicks off with an automated system moving milk through a network of sterile pipes to a pasteurization unit. Here, heat exchangers warm the milk to an exact temperature, typically between 161 and 167 degrees Fahrenheit. It's not just heating, it's a precision process that destroys harmful microorganisms while keeping the milk's nutrients intact. The secret lies in the control system. High-precision sensors continuously monitor the milk's temperature. Once the milk has been heated for the required time, it's cooled down almost instantly to a safe 39 degrees Fahrenheit. Here's where it gets innovative. The heat released during cooling is reused to warm the next batch of milk. This energy regeneration is both cost-effective and eco-friendly, reducing the production's overall energy consumption. In the warm halls of the cheese factory, where the milk has already been pasteurized, the next step begins, adding the starter culture and rennet. The pasteurized milk is poured into large stainless steel vats, where it's heated to around 86 to 89 degrees Fahrenheit, the perfect temperature for the starter culture to do its magic. A computer system controls every detail, from the milk volume to the exact temperature in each vat. The starter culture goes in first. These are carefully selected lactic acid bacteria that give cheddar its signature flavor and texture. Delivered as either a powder or liquid, the culture is measured precisely by robotic dispensers. Once added, large mechanical paddles gently stir the milk, ensuring the bacteria are evenly distributed. Next comes the addition of rennet, a microbiological enzyme called rennin. It's eco-friendly and even suitable for vegetarians. Adding rennet is where the magic happens. It transforms the milk into a curd in less than an hour, laying the foundation for cheddar. While the rennet works its magic, the system keeps an eye on every change in the milk. Sensors measure acidity and density, while algorithms determine the exact moment to end this phase. Modern technology ensures the process is quick, efficient, and requires minimal human intervention. Once the curd is fully formed, the milk is no longer a liquid. It has become a smooth, tender cheese mass, ready for the next step in becoming the famous cheddar. Cheddar is the reason I took my first steps in cooking. Actually, I've taken a lot of steps since then, but I still feel like I'm standing in the same spot. But let's not talk about that. Let's talk about 10-year-old me trying to cook for the first time. Picture this. Me, a heated pan. My mom watching from the corner of the kitchen, ready to call 911 if needed. And there they were. 2 slices of bread slathered with butter and a generous slice of cheddar. Sure, the bread got a little burnt, but it still tasted incredible. By the way, what was the first thing you ever cooked? Forming the curd is when cheddar starts to take physical shape. Every parameter, temperature, acidity level, enzyme timing, is carefully monitored. Sensors continuously measure the milk's density to determine when the curd has reached the ideal consistency. which takes about 30 to 40 minutes. Look at this giant vat. The milk seems to have frozen in time, turning into a soft, gel-like curd. Once the sensors confirm the curd's structure, special knives come into play. These are automated paddles fitted with blades that gently cut the curd into small cubes. They move slowly and evenly to maintain uniformity, which is essential for separating the whey later. At the same time, the vat is gradually heated to around 100 to 104 degrees Fahrenheit. This secondary heating helps expel whey and solidify the cheese granules. As the whey separates during heating, it's drained through special valves at the bottom of the vat. This process is also automated, ensuring just the right amount of whey is left to maintain the cheese mass's proper consistency. What remains in the vat is dense yet tender curd, ready for the cheddaring process. You've been waiting for this part, haven't you? The curd, now formed into large chunks, is transferred to special tables or conveyor belts made of stainless steel with built-in heating systems to maintain the optimal cheddaring temperature of around 95 to 100 degrees Fahrenheit. The curd is stacked into layers, distributed evenly by robotic manipulators or conveyor systems. These layers rest for a specific time, allowing them to bond and compress. Under its own weight and the steady temperature, the curd releases residual whey. After a certain period, the layers are flipped over. A key feature of the cheddaring process is the gradual acidification of the curd. This happens thanks to the lactic acid bacteria added earlier with the starter culture. Their activity alters the cheese's chemical composition, giving it a mild, slightly tangy flavor. By the time cheddaring is complete, the curd becomes dense, elastic, and ready for the next step, cutting and salting. Automated cutting systems divide the curd into equal pieces, ensuring consistent weight and size for every portion. At this point, my friend, we're one step closer to achieving cheddar's authentic flavor and texture. Now the curd, firm and springy, moves along specialized conveyors. Come closer and take a look. This is where the curd is cut into blocks or cubes, depending on the intended product. Next, it's time for salting. In the US, two main salting methods are used: brine baths and dry salting. The choice depends on the recipe for each batch of cheddar. In brine baths, large tanks are filled with a salt solution, where the cheese is submerged for several hours to allow the salt to penetrate its structure. For dry salting, the cheese blocks travel along a conveyor, passing through machines that evenly sprinkle salt over them. Salt serves a dual purpose. It enhances flavor and acts as a natural preservative, protecting the cheese from unwanted microorganisms. During this stage, the cheese continues to release residual whey, which automated systems collect and process for further use or recycling. And now, it's time for aging. This, by the way, is something I have zero patience for when it comes to cheddar. The cheese blocks are sent to special aging rooms, also known as maturation chambers. These chambers are equipped with modern climate control systems that automatically maintain optimal conditions for cheddar to age. Temperature, humidity, and air circulation are regulated with precision, down to the tenth of a degree or percentage, because even the slightest deviation can impact the cheese's quality. Cheddar is typically aged anywhere from a few months to several years. Young cheddar has a mild, creamy taste, while aged cheddar develops a rich, tangy flavor with a crystalline texture. The aging duration is determined during the batch planning stage, and all parameters are recorded in a centralized computer system. Robotic manipulators carefully stack the cheese blocks on racks in the aging chambers. These robots are programmed to minimize contact with the product, ensuring a high level of hygiene. The rack systems are also automated, capable of rotating or moving the blocks for even aging. Throughout the aging process, the cheese is closely monitored. Automatic sensors in the chambers continuously check the microclimate and even analyze gases released by the cheese to track chemical changes in its structure. In some cases, cheddar is coated with a layer of wax or a special film to protect it from drying out and environmental exposure. For aged varieties, dry aging is sometimes used, leaving the cheese uncovered to form a natural rind. When this method is chosen, automated systems periodically move and flip the blocks, cleaning them of any accumulated dust or mold. Here we are, standing at the entrance of a massive cornflakes factory. Did you know that around 4 billion pounds of cornflakes are made worldwide every year? Impressive, right? You ready? Let's go. I'll walk you through everything step by step, from the very beginning all the way to how these crunchy, delicious flakes end up on your breakfast table. It all starts in the cornfields. For cornflakes, a specific type of corn is used, yellow dent corn. This variety isn't like the sweet corn we're used to eating boiled or grilled. It's starchier and contains less sugar, making it perfect for processing. The corn is harvested using massive combines that literally slice through the fields, stripping the cobs and separating the kernels. From there, it's sent to the factory. Before transportation, the corn is carefully dried to reduce moisture and preserve its quality during transit. At the factory, the kernels undergo hundreds of tests. They're checked for size, density, moisture levels, and even color. Every detail matters to create perfectly uniform and crispy flakes. And when it comes to cornflakes, the most iconic brand is still Kellogg's, which first introduced them way back in 1894. Cornflakes, like many culinary inventions, were born out of a mix of chance and experimentation. They were created by the Kellogg brothers, John Harvey Kellogg and his younger brother, Will Keith Kellogg, in the late 19th century. John Harvey Kellogg was a doctor and the director of a sanitarium in Battle Creek, Michigan, USA. His sanitarium followed strict principles of healthy living, offering patients a plant-based diet, physical exercise, and even some rather radical treatments, like hydrotherapy. One of John's main goals was to develop healthy and easy-to-digest food for his patients. Will Keith Kellogg, his brother, worked alongside him at the sanitarium, handling administrative tasks and helping bring his ideas to life. In 1894, John and Will were experimenting with different ways to process grains to make them easier to digest. One day, they cooked a batch of wheat dough, but accidentally left it out to dry for too long. By the time they returned, the dough had become overly dry and brittle. Curious, they decided to run it through rollers to see what would happen. To their surprise, the result was thin flakes, which they toasted to make crispy. The patients at the sanitarium loved them. Later, the brothers decided to try experimenting with corn, as it was cheaper, more widely available, and delivered even better results. And just like that, cornflakes were born. After the success of their flakes, Will Keith Kellogg saw massive business potential and wanted to sell them on a larger scale. However, John Harvey Kellogg disagreed. He viewed them solely as dietary food for patients. In 1906, Will founded the Kellogg's Company, which remains the world's largest producer of cornflakes to this day. The production scale has grown so much that Kellogg's now uses over 1.5 billion pounds of corn every year. Cornflakes became a massive hit in the US, especially among women who loved them as a quick and easy breakfast option. The original recipe was simple, just corn, salt, and a little sugar. Today's versions come in dozens of flavors and include all kinds of additional ingredients. Now here we are inside the production floor. Huge silos are filled with corn, which is gradually fed into the first stage, cleaning. Specialized machines remove debris, stones, leftover cobs, and husks. Next, the corn goes through a magnetic separator. You might be wondering, why a magnet? It's to ensure no metal fragments from harvesting or transport make it through. Once the corn is thoroughly cleaned, it's sent to giant tanks filled with hot water. Here, it cooks for several hours at around 212 degrees Fahrenheit. This softens the kernels and allows them to absorb moisture, preparing them for the next stages of processing. After boiling, the corn is moved into machines that separate the germ and the hull from the kernel. The germ, the part of the grain that's packed with oil, is removed so the flakes don't turn out too greasy. Once the kernel is cleaned, it's ready for the next step, roller processing. And here's where things get really exciting. The cleaned corn kernels are poured into specialized steel rollers that, under immense pressure, flatten each kernel into a thin sheet. These rollers spin at incredible speeds, and the entire process happens almost instantly. Watching it in real time feels like magic. Corn literally transforms into flakes right before your eyes. The flattened kernels now resemble thin, golden discs. But hold on, they're not quite the flakes you're used to eating just yet. Now we're getting to the massive ovens. This is where the flakes are dried and toasted at around 482 degrees Fahrenheit. It's here that they develop that perfect, crispy texture and beautiful golden color. Imagine the smell in this room. It's like popcorn, but sweeter. At this stage, a touch of sugar, salt, or even honey is added to the flakes, depending on the recipe. For glazed flakes, they're coated with a thin layer of sugar syrup that caramelizes right in the oven. How many crunchy flakes could you eat? Fun fact, there's even a championship for speed-eating cornflakes, and the record stands at 16 ounces in just 1 minute. Crazy, right? Now watch as countless hot, crispy flakes roll off the conveyor belt. But not all of them make it into the boxes, only those that pass quality control. Special machines check their shape, thickness, and even the sound they make when they break. Seriously, that's a real quality measure. Once the flakes are ready, they're cooled and packed into bags. The machines automatically weigh each portion, seal it in foil-lined bags to keep it fresh, and place it into cardboard boxes. It takes about 3.5 ounces of corn to produce 1 box of flakes, but growing that amount of corn requires 5 gallons of water. Here's a fun throwback. In the 1980s, a British company tried selling cornflakes in cans, like soup, but the idea flopped because customers thought it looked too weird. Almost 100% of cornflake boxes are made from recycled cardboard, and the printing is done with soy-based ink. Here we are, standing next to the warehouse filled with ready-to-go products. Just imagine, these boxes of cornflakes are about to head out to every corner of the globe. They'll be breakfast for kids in the United States, snacks for students in Europe, or even a key ingredient in desserts across Asia. Fun fact, cornflakes were actually invented in the United States, but today they're a hit in over 180 countries worldwide. Modern factories take eco-friendliness to the next level. Leftover corn from processing gets repurposed as livestock feed, and the cardboard boxes? They're made from recycled materials. Oh, and here's a surprising twist. In some farming communities, cornflakes are actually used as cattle feed. Farmers discovered that cows love this stuff. Cornflakes have even made it to space. They were included in the diets of American astronauts during NASA missions. Every year, more than 6 billion servings of cornflakes are consumed worldwide. That's enough to feed the entire population of Earth breakfast for 3 weeks straight. And here's something crazy. Listen closely. If you place a magnet near cornflakes, they might actually move toward it. Why? Because cornflakes are fortified with iron, an essential nutrient for human health. Have you tried it yourself? Drop a comment and let us know what happened.